Today's lesson is on the topic 6 review. The vertices of ABC are A11, B 3, -2, and C -5, 3. What are the coordinates of A prime, B prime, C prime after translation 4 units down and 2 units right? Take a second to copy down that part of the problem, and then we'll work on the rest. So for a translation, we're going 4 down and 2 to the right. The up and down refers to the y-axis. So since we're going 4 down, we're going to subtract 4 from the y. And 2 to the right refers to the x-axis, and to the right is positive, so it'll be our x value plus 2. So I'm going to do that for every point. A prime, 1 plus 2 is 3, and 1 minus 4 is -3. B prime, 3 plus 2 is 5, and -2 minus 4 is -6. And C prime, -5 plus 2 is -3, and 3 minus 4 is -1. So those are my points after a translation 4 units down and 2 units right. The next question, what are the coordinates of A prime, B prime, C prime after a rotation of 270 degrees? Take a second to copy down that problem. For a rotation, I'm going to use my shortcut, and I'm going to start with point A. So from my shortcut, I take my back number to the front, and I change the sign. So it becomes -1, 1. That was only 90 degrees, so I have to do it again. When I do it again, I get -1, -1. Now since that was twice, that's 180. So I do it one more time. When I do it one more time, I get my final answer of A prime, which is 1, -1. Because I move my back number to the front and I change the sign. Now I'm going to do the same process for B. 3, -2. My back number to the front and I get 2, 3. That's 90. My back number to my front, -3, 2. That's 180. And then one more time, my back number to the front, I get -2, -3. And that would be my 270 degrees. So for B prime, I get -2, -3. Now for C, I start with -5, 3. My back number to the front, -3, -5, that's 90. Back number to the front, and change the sign, 5, -3, that's 180. One more time, my back number to the front and change the sign, I get 3, 5. And that would be 270 degrees. What are the coordinates of A prime, B prime, C prime after a reflection over the x-axis? Just so I make sure I have my answer, I'm just going to draw a little graph and plot my point A, which is here at 1, 1. If I want to reflect it over the x-axis, I'd have to move it one space down to get to my x-axis, and then one more space, and I would end up down here. So that point for A prime would be 1. My x value stay the same, but my y value change. So it'd be 1, -1. Now, since I see that for all of my points, my x value stays the same and the y value changes, I just do the same thing for my other points. For b, my x value of 3 stays the same, and my y value of negative 2 changes to positive 2. For point c prime, my x value of negative 5 stays the same, but my y value changes from 3 to negative 3. And the last question, what are the coordinates of a prime, b prime, c prime after a dilation of 2 units? A dilation just means that I am multiplying every single number by my scale factor. In this case, my scale factor is 2. So for point A, 1 times 2 is 2. 1 times 2 again is 2. For b prime, 3 times 2 is 6, and negative 2 times 2 is negative 4. And for c, negative 5 times 2 is negative 10, and 3 times 2 is 6. And remember, with all of these questions, make sure that you are labeling them with your prime. If you do not label them correctly, you will not get full credit. Every one of these problems I labeled with my prime. The second question. A triangle with a perimeter of 13 centimeters is rotated and reflected. What is the perimeter of the resulting image? Take a second to copy down the question. So for this problem, since my image is rotated and reflected, when an image is rotated and reflected, that produces congruent figures. So congruent figures, everything is exactly the same. The angles are the same, the side lengths are the same. So since the perimeter was 13 centimeters, the perimeter of the resulting image is just 13 centimeters. The perimeter stays exactly the same as the original image. Is figure 1 similar to figure 2? Take a second to copy down the question and a picture of the diagram as well. When images are similar, that means that the sides are proportional. So when I look at this, I'm going to look at my side lengths and see if they are proportional. For my bigger figure, I have 3 and 3, and those correspond to the 2 and 2 on the figure 1. So if I were to do 3 divided by 2, when I do 3 divided by 2, I get 1.5. Now I'm going to look at the bigger size of each figure. Figure 2 is 6 and 6, and figure 1 has 4 and 4. So since I did figure 2 in the numerator for my first fraction, I'm going to do figure 2 in the numerator as well. So I'll have 6 divided by 4. 6 divided by 4 is equal to 1.5. So since these two are the same decimal, my side lengths are proportional. So I can say that figure 1 is similar to figure 2. In the given diagram, line C is parallel to line D. What is the measure of all of the angles? Take a second to copy down the question and the diagram as well. Now for this problem, I'm just going to label the measure of the angles inside the diagram. This is my angle of 75. Angle 8 is going to be the same measure because they are vertical angles. Vertical angles are congruent. I can also look at this top part and see that angle 2 is corresponding to this angle of 75 degrees, so angle 2 would also have to be 75 degrees. Angle 4 and angle 8, they are also corresponding, so angle 4 would also have to be 75 degrees. Now I have to determine the angle measure for angle 7. I see that I have a straight line here. A straight line is always 180 degrees. So since this angle is 75, if I do 180 minus that 75, I get 105. So that means that angle 7 would be 105 degrees. Angle 7 and angle 5 are vertical, so angle 5 would also be 105 degrees. Now to get my top angles, I can look at my corresponding angles. Angle 7 corresponds to angle 3. So that means that angle 3 is also 105 degrees. Angle 1 corresponds to angle 5, so that would also be 105 degrees. So anytime you're finding the measure of angles when you have parallel lines that are cut by this third line, make sure you use your corresponding angles to determine if the angles should add up to 180 or if they should be equal to each other. What is the measure of every angle in the given diagram? Take a second to copy down the question and a picture of the diagram as well. When I'm looking at my diagram, I notice that I have two triangles. I have this triangle up top that is outlined in red, and then I have another triangle that I'm going to outline in black, and that is this triangle down here. I also notice I have this 121.8 degrees that is outside of the triangle. So this is an exterior angle of my triangle. I know that the exterior angle of a triangle is equal to the sum of the two interior angles that it does not touch. So this exterior angle does not touch this angle or this angle. So I can say that 121.8 is equal to the measure of angle 2 plus 17.3. To find the measure of angle 2, I can subtract 17.3. I can subtract 17.3 from both sides. On the right hand side, I'm left with the measure of angle 2. 121.8 minus 17.3 is equal to 104.5. So the measure of angle 2 is 104.5. Now, I also have to find this missing angle down here that I will call x. I notice that here I have a straight line. A straight line is 180 degrees. So to find x, I can do 180 minus 121.8. When I do 180 minus 121.8, I get 58.2. So this angle is 58.2 degrees. That covers all the angles of my smaller black triangle at the bottom. Now I need to find the measure of the angles of my top triangle. This triangle I'm going to do a little differently. I see I have a straight line here as well. This angle measure I'm going to call y. To find y, I notice that it would have to be the straight line 180 degrees. So I can do 180 minus 104.5. When I do 180 minus 104.5, I get 75.5. Now I start to find the measure of angle 1. I notice I have 2 of the 3 angles inside my triangle. That means all 3 of those angles inside the triangle have to add up to 180 degrees. So that means that I have 37.1 plus 75.5 plus the measure of angle 1 has to equal 180 degrees. 75.5 plus 37.1 is equal to 112.6 plus the measure of angle 1 equals 180. Now to solve for the measure of angle 1, I can subtract 112.6 from both sides. And I'm left with the measure of angle 1 equals 180 minus 112.6 is equal to 67.4. So the measure of angle 1 is equal to 67.4 degrees. And the last problem, are the 2 triangles similar? Take a second to copy down the question and the diagram as well. In order to determine if these 2 triangles are similar, I have to find the value of x. I see I have 2 vertical angles here. Vertical angles are always equal. So I know that 6x minus 2 is going to have to be equal to 5x plus 10. Now I'm going to solve this for x. I can subtract 5x from both sides. 6x minus 5x is equal to 1x. Minus 2 comes down. 5x minus 5x cancels out, and I'm left with 10. I can add 2 to both sides, and I get that x equals 12. Now, I'm going to use that x equals 12 to find the measure of every angle in both triangles to see if my 2 triangles are similar. This first angle, I can have 5 times 12. 5 times 12 to give me the measure of angle J, and 5 times 12 is 60 degrees. So angle J is 60 degrees. I can use that same x to substitute into the 6x minus 7. 6 times 12 minus 7. 6 times 12 is equal to 72. And 72 minus 7 is equal to 65 degrees. Now, I can find the measure of these 2 angles here at the vertex of L. 5 times 12 plus 10. 5 times 12 is 60, plus 10 gives me 70. So this angle measure is 70 degrees, and I know that this angle measure is also 70 degrees because they are vertical angles. I'm still missing the measure of angle K and the measure of angle N. I'm going to look at measure of angle K first. I have 60 and 70 in my triangle. I know that the triangle has to add up to 180 degrees. So the measure of angle K plus 60 plus 70 has to equal to 180 degrees. 60 plus 70 is 130. So the measure of angle K plus 130 has to equal to 180 degrees. I can subtract 130, subtract 130. The measure of angle K is equal to 50 degrees. So angle K is 50 degrees. Now, in order for triangles to be similar, you need to have two angles that are the same. In this triangle, I have 60, 70, and 50. In my other triangle, I have 65 and 70. I have to find the measure of angle N now. I can do my same process that I just worked through. The measure of angle N plus 65 plus 70 equals 180. 65 plus 70 is equal to 135. The measure of angle N plus 135 equals 180. I can solve this for the measure of angle N by subtracting 135 from each side. The measure of angle N is equal to 45 degrees. So now I look to see if my two triangles have two angles that are the same. They only have one angle that's the same, it's the 70. So the two triangles are not similar.